I've been having a great time learning and educating myself and getting better at understanding what kind of performance characteristics can be manifested on different types of systems under different types of conditions over the past 3 months on my AI home lab server that I've built here. This is actually really cool. I've had a lot of fun doing it, and today I wanted to impart some of the tips, tricks, some gotchas, and some things that I think I've filed under lessons learned myself. So I hope you're excited for this. If you're interested in Black Friday or Cyber Monday deals, definitely check this video out first, because this will give you some ideas of things that you can avoid to possibly save yourself some heartache, and also to get the right system right off the bat for you. The primary, most important thing, and that is VRAM. VRAM is going to be your main go-to that you're going to want to optimize for under all of your conditions. The higher the amount of VRAM you have, of course, is better. There's multiple different ways to get there, so you might be under some impressions that you can't mix and match things. Let's start with addressing the GPUs. We're going to go component by component here. That way we can kind of segment this down into chapters. You can check those down below as well, all the links and the written guide that I also have to accompany this in case you might forget some of this. So one of the biggest takeaways is that you can mix and match your generations. So that means a Pascal 1080 could be mixed with something like a 3070. You can mix a 4090 all the way down to a K2200 even. So there's a lot of capacity to grow your VRAM cheaply. However, the impact of it is essentially the lowest common denominator for your inference performance. So your inference performance is going to be limited by the slowest of the GPUs that you have in your system, and they're all going to go there. So do be careful. You will sacrifice performance if you were to do something like pairing a 4090 with a P2000. It will actually slow things down versus another add-a-class machine. How many GPUs can you fit in a system? So you don't need full 16x lanes. I put this rig together with that expectation, but I also wanted to get into training on this rig. And if you do want to do training, you definitely do need to have full 16 wide lanes. At that point, you're looking at a server class hardware kind of setup. Something like a Threadripper Pro can also work in that scenario. But those are going to be things that you definitely have to have happen. So if you're looking for just regular inference, you can get by with even 1x PCIe risers, or you can get bifurcation splitters that could help you run multiple GPUs off of a single slot. I think most people, however, are going to be constrained mainly by the budget. So I would not suggest you actually get into a rig rack like this until you're spending probably in the about $2,500 range, and you would want to have multiple GPUs to necessitate being in this kind of a setup. You can actually get 2 GPUs in quite a few different consumer cases out there. Now, that can have some pretty bad impacts of covering an extra slot that could be useful, but you can use some of the PCIe risers that I've used, and that will get you the ability to move those cards to different locations. Of course, in a rack, easier to do. You might only have 1 or 2 locations depending upon a case that is like a consumer desktop case that you would be moving things. One thing to watch out for, this one is not a favorite of mine. Llama.cpp and Ollama. So underneath the hood, Ollama uses Llama CPP for doing the actual communication with the model, and that is unfortunately got some limitations about how it parallelizes. So one of the most frequent questions I get asked, will this be able to get the same performance times 2 if I put 2 GPUs in? No, it will not currently with Llama CPP. Now, there are changes that are being worked on that do purport to have the impacts. I'm keeping my eye on those, and you can be sure I'll tell you when that happens and be using it and demonstrating it myself. Look forward to that day a lot, but that is something that is still under work from what I've seen, and it has not had its pull request finished out here, so that software is not yet done. Other software runners can actually handle that, like VLLM under the hood. So you do get more performance, but you don't necessarily get quite the ease of use that you get with a Llama. A Llama is really nice and fast to get up and running. It's probably one of the easiest platforms out there. It's why I like featuring it a lot on this channel also. It is actually really easy even for my wife to use to get things done, pulling down a model, checking something out. It's just really, really nice. Your system is really going to be geared towards being an always-on machine. So you're going to want to optimize for wattage if you have a high cost per kilowatt hour. Intel is going to do better. Most of the GPUs on the modern drivers that I'm seeing, even the 3090s, which are notoriously power hungry, only idle up to 10 watts a piece. So there is something to be said with idle state management. Something like a K2200 or a P2000, seeing it at 1 watt is not uncommon when it's idling. So you can go pretty low on them also. The 3060 12GB that we reviewed recently, really good card. That one was idling somewhere around 3 to 4 watts. That's really good if you have an always-on system. So if you're looking also at some of the things that you should watch out for, you probably want to, when you're looking at your GPUs, consider that you don't necessarily have to clean them. That was one of the things that I did early on, but if your workload is primarily inference, you're not going to generate enough heat to really necessitate it. Cleaning your GPUs is something you could do, but do understand there is associated costs with it, and there's a lot of time that goes into it, as well as it's just dirty and kind of meticulous little work. So once you get into it, this first one especially, it's a lot of effort. So you may not need to clean your GPUs. So I would recommend, if you're in a garage or something like that, to do the best you can to mitigate things. You can watch some of the videos that we've done prior in this channel to learn more about that. So this gets into why you need to potentially have 2 GPUs. It's not a bad idea if you have 2 types of things happening at the same time to give yourself some slack room with an extra GPU so that you can have work that might not be associated. Say you're doing some transcoding or something like that, you might have that kick over to the other GPU and not the primary GPU that might be used for models and inference. That way you don't have to push one of them out of VRAM and create a huge bottleneck as far as performance. Sometimes you even have to manually go in and kill and restart the processes. That can be a pain. Best to avoid that. Again, VRAM is king. This is another very popular question, which we were finally able to get a little bit of information around. The Apple M4s, and so we had somebody that had an M4 Max drop some statistics on the latest 32B model that just, I dropped that review earlier today. Quinn with questions, and so Quinn with questions is based off of a 2.5B Quinn model. And so the Apple M4 was able to hit about 11.11 tokens per second, according to somebody's reports online. And that was at a Q4 depth versus the 20.63 tokens per second that I got on the quad GPU rig that's over there. So you can see there's quite a big difference there. And the price difference is something to consider also. I do think that the Apple options for really large models make a ton of sense possibly. I'm not sure what the tokens per second would be like. And I find myself very much gravitating more and more towards, if it's not in the mid-teens as far as speed for tokens per second, it just, it doesn't really, I need more. If you know what I mean. Let me know in the comments below what your preferred tokens per second are. But definitely when you have something that is meandering around thinking touchingly humanly, like the Quinn latest model that we reviewed, you definitely want to have a good tokens per second on that. So you would sacrifice precision, in my estimation, to achieve a better tokens per second. These trade-offs are never easy, and I urge people to try them out for themselves. Next, let's move on to power supplies. This one's pretty quick for me to cover, and based upon what I've seen, getting a good power supply that is capable of 1500 watts is, if you're gonna build a rig yourself, a good idea. If you are going to potentially grow it in the future, 1500 watts is gonna get you pretty far. Now, that is with 43090s, probably a problem if you're aware of what the max wattage is. However, due to the same problem that I mentioned earlier about parallelization and how Llama CPP is handling it, you're not going to run 100% GPU workload on all your GPUs. So as a result of that, it actually draws significantly less watts. A good 1500 watt PSU is still what I would stick with. If you're gonna go bigger than 4 GPUs, of course you're gonna be looking at a dual GPU setup, and at that point you might start thinking about a 30 amp or a higher kind of capacity setup. That would be my recommendation. Certainly we're gonna have one of those that we put together that's gonna be dedicated on this channel, so make sure you hit like and subscribe and ring the bell so that you get notified when we do that. As far as the next thing that is a really quick one to cover, RAM speeds. So we tested this out extensively on even a 7995WX with 6400 speed RAM, that's DDR5, versus 2400 speed RAM. And we saw shockingly, I would say definitely shockingly, not that big of a difference at all based on the RAM being the one thing that changed. That is something that you should consider a pretty primary takeaway in my opinion. If you're spending your money on fast RAM, there are some reasons to do that, possibly, but I think it's much better spent on increasing the amount of VRAM in your system. And so, like I mentioned, the Intels are going to idle better. However, the AMDs are usually going to give you some of the best bang for buck. Also, those systems are pretty cheap online used. Second, another big thing here to consider, you definitely want to get, this is a finding that is key that we did see, a faster single thread speed CPU if you can. Now, this is important for a couple of reasons. It gives you much better inference readout speed, so you're actually able to read the tokens per second faster because the clock cycles are happening faster on your system. And so we saw the difference between a 5.2 and a 3.2 was roughly on the order and magnitude of 5 tokens per second difference between those two. So I'm going to just blanket state probably about 2.5 tokens per second gain could be had by going each gigahertz faster on your single thread speed. If you are looking at a balance point between how many CPU cores you need, well, you can get by on 4. You can, I think that's the base size that you're going to find the smallest that they're going to be available. So 4 is definitely possible. You're of course going to have a system that's kind of scaled down at that point at any rate. You're not probably going to be running 2 or 3 or 4 models. You're probably not going to be doing a terrible amount more on that system if you're doing inference at the same time. If you're looking at a large core count, like I've got the 7702 here, and that is because I have also another 64 core machine, and I already had both of these here. So like having one that can fail over to another is something that is a core component of my home setup for my home lab, garage data center, whatever you want to call it. So I would urge you to consider if you have a setup that is HA or something like that, you're probably going to want to mirror whatever the other is. So 64 core is what I mirror over to. And of course, those are AMD EPYC systems. That allows me to run tons of VMs and additional things, 256 gigabytes of RAM, as well if I really wanted to run a CPU-based model for something like a 405B, technically is possible to do. However, the tokens per second, pretty unsatisfactory in my opinion. So you would really want to narrow down on your prompting so that it gave you a quick reply for that. Something that isn't a surprise that I didn't actually factor in. You can actually run some of these much smaller models pretty actually good on just CPU alone. That could also benefit from having a large CPU core count. So I did see, I think it was a 1 billion or something like that, running fairly decently. So that is something to consider. Again, at that point, RAM speed might impact you more, but I didn't see that it was actually that bad. So it was an acceptable performance level for tokens per second at a 1B. Now that did use quite a few cores, but it's able to do that really intelligently and span out. Something to keep in mind. I would actually suggest that you consider one of the F in the Rome series chipsets if you are looking at what to get, because the 7F52 is a really nice balance between number of cores and speed. Also, if you can go up to the Genoas, those are of course going to be really good. And now let's move on to the motherboard. Wow. Motherboards, I've got to say, have a lot of impact on how much headache you're going to get into. So if you're looking at servers or workstation motherboards, keep in mind, you're going to have some good things that come along with that you should definitely weigh as quality of life improvements across the board. The biggest one being the ability to remote in through an iKVM that's built into the system and control it, have a monitor display, do all of the stuff that you might need to do with virtual media like load and ISO. Very nice to have that. You can actually get remote eyes on your system really easy. The MZ32AR0 has a V1 and a V2. So the V1 that I have, I was actually able to upgrade that with the same firmware to the V3. I can't tell you that's a good idea, and I'm not recommending it, especially if you're going to go and break your motherboard. So do be careful about that if you do choose to do that. But mine did actually make that jump up. As well, it's a cheaper motherboard. Now, I will say this. It actually kind of has an interesting possibility if you wanted to run 4 additional GPUs in the bifurcation setup off the 4i small form factor NVMe cables that I actually have bridged over, which is that weird thing that I covered in this setup video for this MZ32AR0 that you should factor in. Now, those cables also cost money. This makes the H12 SSLI, that's a super micro motherboard, a pretty good thing to consider. And the reason why is that that super micro motherboard is significantly less fiddly. Its BIOS is much clearer, and you can find tons of people that have experience with the super micro BIOS settings, so you're not gonna run into weird settings that you don't understand what they might do. You will run into that possibly on the Gigabyte MZ32AR0. It is a lower price, but if you're gonna buy those cables to span over, make sure you check the price of the H12 SSLI at the same time. Both of them are capable of running a 7003 EPYC, which is a great CPU. However, the Rome 7002 class series is of course where most of the value is. Getting 256 gigabytes of RAM, you can do that so cheap now. It was really expensive when I bought my RAM, but you can get RAM so cheap now in DDR4, so I would urge you to consider that. Also, of course, server RAM, able to go up to much larger sizes than you might get in your desktop setups. Factor in all those things when you're planning out your home lab before you go and buy one component. Think about the entire system. And again, everything should come back to, is that going to be enough GPU VRAM for what I want? There are different classes of rigs, and I think one of the biggest things that we're going to talk about here is the cheap side of how cheap you can go. So we've got a rig that we're going to have a video out on that goes all the way down to $150. This is actually a pretty attractive price point using something like a K2200. K2200 is actually, in my opinion, a better deal because you can get 2 of those easily for the price of one P2000. And that gives you 8 gigabytes of RAM versus 5. However, you're going to be slot limited if you're in something like a Dell Optiplex. There's just going to be so many slots that you have. If you move into the precision line, you probably will have some power, so you could do something like a 12 gigabyte card like we covered in a recent video where we put together the $350 build system, but that's gonna be the next step up really. Once you get to 12 gigabytes, you can start doing some pretty cool stuff. You can really run vision models that are impressive. I mean, the capabilities that we were looking at with the vision model in that video were really good. Now, running a 9dB and an 11B, I can say there is a difference for sure, but it is not as big of a difference as you might expect. So the 11B still performs, I would guess, probably 75, maybe 85% as well as the 9dB. So you get most of the performance at a Q4 even in a 12 gigabyte VRAM card. So there's trade-offs, but they're not quite as pronounced as you think. Again, the balancing point is how much VRAM you have and how many models you want to run. Up to $500 might be a Z440. Those are really good and affordable. They also have external power adapters for them, so you can run 2 external GPUs as long as they're not drawing too much power. Your inference workloads are sporadic. Of course, training would definitely be something you would want to have a much better dedicated power supply for. And in there, you can expect to get at least a 12 gigabyte, possibly a 16 gigabyte, because you could add on an extra 4 gigabyte card fairly easily to that and cheaply at the same time if you're willing to sacrifice some performance. But like I mentioned, there may be some good scenarios where you want to run a vision model on one card and you might want to run an sundry of other smaller models on another card. So that is an easy way to get up and running. Next, I think you've got to look at your mid-tier, and you're probably going to be able to hit somewhere around 24 gigabytes pretty easily. That's thinking that a 3090 is somewhere in the $750 range. Again, I would say the 3090, in my opinion, is still a better value option than a 4090. Of course, you do have the 5090 series coming out and the complete series is going to have more VRAM, it looks like. So there's a lot of decisions to be made there. I'm sure that we'll talk more about those in the future. Hopefully I can get my hands on some 5090s. But when we're looking at the trade-offs that have to be made for the amount of VRAM you have, having a single card that is a 24 gigabyte card can provide a lot of additional benefits, especially people are reporting benefits with things like being able to do video. And so there are some open source video out there now that can run through Comfy UI even. And I haven't had a chance to play with them yet, but it definitely looks like Lightricks has released a really good model, and a 24 gigabyte 4090 is able to generate about 12 seconds worth of video. So I'm pretty excited to check that one out. I'm not sure if they're going to get multi-GPU support, how far that out is, but definitely single GPU for doing things like image generation and video generation is something you should factor in. 4090 is of course going to really smoke on that. If you're not going to do that, or that's not a primary use case, then you might consider a 3090 is still a really good amount of capabilities at a significantly lower price. 750-ish, maybe 800 is kind of the price range that they were at last I checked. Of course, your 4090s significantly higher, like significantly higher.
So if you have a hankering for insanity, the Quad 3090 rig, you can follow along with the written guide, also with the additional markup that I put about getting some of the whole realignments done, and of course the entire video that covered me step by step putting that together at the links in the description below. And also be sure to check out the AI Home Lab Server Takeaways, which is a good guide on things that you definitely want to consider. This will help you be a more informed buyer, and I thank you for patronizing and checking out this channel. And also make sure that you hit that like and subscribe while you're down there and leaving a comment.
So if you are looking at, and this was somebody's question they had specifically to me, eBay or something like that similar, for a used CPU, you do want to look at the reputation of the seller, and you also want to read the reviews that the seller has. And I would recommend reading all the way back to a problem issue that the seller encountered that is dealt with in a positive manner as a good indicator that that is somebody you would want to do business with. And also make sure you, of course, check the shipping policies and also the return capabilities, and give yourself enough time to try out the system. If you have other parts that are delayed, it could really be a hindrance to you effectively testing out your system. You don't want to run into that. If you follow those two steps right there, you're going to eliminate most of the problems, in my estimation, that you're going to run into on eBay. Can't tell you that's 100% certain, but of course there's Amazon if you want to sidestep almost all of the headaches that you could run into. So keep that in mind. Those are just my estimations of how to keep those problems at bay. Your CPU definitely is an expensive part if you're looking at an EPYC or a Threadripper Pro. Let me just drop another nugget on you. CUDA may not be supported in the incredibly far future. I can't say when or when it won't be supported by the software. So those are going to use CUDA 11. CUDA 12 is generally much safer, and cards that can support CUDA 12 are generally going to be considered much safer. So like your Pascal's on, in my opinion, are going to have a longer lifespan because the software developers, at some point, they may stop writing support for the CUDA 11. Now that probably has to do with some matrices of what kind of features they can offer and performance that they can offer possibly. I'm not 100% certain on that, but do keep that in mind. One of the reasons I would say you're looking at K2200s because why? If it's just because they're cheap, you might be better off getting a single Pascal 2000 or even a 1070 if you have the capacity to plug in to an additional power supply. Certainly you wouldn't want to have an open air frame like this around children or many dogs and cats. Maybe an animal could get into that and cause some trouble. Most likely they're going to damage your components and not actually endanger themselves, but still it is something you would want to consider. I also think you have to know that you are going to be okay getting through the modifications. They may not be exactly the same modifications I made to mine, but if your GPUs are slightly bigger, slightly smaller, that could change your placements. You should, before you actually commit to drilling holes, use pieces of paper, mock up the placement that you expect, put the little, notches in there and consider that you need to drill those spots and not just follow along blindly with what I put out there. You probably have to modify it a bit unless you're using the exact MSI 3090 Ventus ones that I'm using, and I do love them and I do recommend them. They are actually really good GPUs. Another thing I'll mention about this rack is that it is a little bit far apart on the spacing, so I feel like you could get an extra GPU in there if the placements for the tapping locations were adjusted. Now that is a lot of additional work and metal work, but if you have a press or something like that, that probably isn't that big of a deal. If you have a hand drill, it might be kind of a big deal. So I would like to adjust it on mine, but at the same time, I'm gonna just call it good enough and not really think too hard on that one. But that is a way you may be able to get, in my estimation, 6 3090s in this rig. So those are some of my thoughts. Hopefully this can help you out if you are thinking about what you're gonna buy or what you're gonna get into or what you are gonna do next to make a better decision with learning from my mistakes. And you definitely need to check out the written website that has all of this information on it, because there will be a bunch of things I did not cover here that are there, and things that may have been said a little bit slightly confusingly here will be definitely stated clearly there. I hope you've enjoyed this, and I will check you out next time.